Good morning, 12th class. Today our topic is Vant Hoff factor. Okay, that one is represented by I, and as we have learned in earlier video, generally to know the extent of association or dissociation when an electrolyte it dissolved in a solution or solvent. Okay, so that generally a factor is introduced, that one is known as Vant Hoff factor, that already explained to you. Now what is Vant Hoff factor actually, and how to calculate that value of I? Okay, so for that simple, actually the Vant Hoff factor, it is the ratio of the observed, basically it's an experimental value of a colligative property to the normal value of the same property, that is known as Vant Hoff factor, and that is represented by I. So simple, it's a ratio of the observed value, means experimental value, okay, and the calculated value of the same property. That one is known as Vant Hoff factor. So simple because it's a ratio. So the formula is, that is I is equal to observed value of a colligative property upon normal value of a same colligative property. Okay, in short, you can write like this also, because colligative property is represented by delta. So delta obs, it's observed, and this one is delta calculated. Okay, now we have other formulas also. You know that colligative property is directly proportional to number of particles present in the solution and inversely proportional to the molecular mass, that we have learned in earlier video. Okay, now just see, so instead of this you can write this formula also. I is equal to number of particles present in the solution upon normal number of particle. This one is for observed one, this one is for normal calculated particle. And instead of this you can write in the terms of molar mass also, but in opposite manner, because colligative property is inversely proportional to molecular mass. So that I is equal to normal molecular mass upon observed molecular mass. So these three formula we can use any one. Now okay, in this one, after that, when state of, this one is again important note, when a state of solution remain unchanged in solution, means suppose you have dissolved something, okay, and whatever is the molecular mass, that one remains same, there is no change. Okay, so in that case I is equal to 1. But if solute undergoes association, means combine होते हैं and their number of particle decreases, in that case I is less than 1. And if they undergoes dissociation, means number of particles increases, okay, that one is also showing abnormal molecular mass, in that case I is greater than 1. Okay, this one is simple note. Now I think we have learned colligative properties, their formula. If you know all these formula, so we have some modified equation for colligative properties. Modified equation means we have learned this thing. For relative lowering of vapor pressure, our formula is P naught A minus PA upon P naught A is equal to mole fraction of solute. Now you have to I, only Vant Hoff factor you have to introduce. Now another one is delta TB, that is equal to Kb into M, it's a molality. Okay, again I you have to introduce. Same formulas are same for delta TF, depression and freezing point. Okay, same I introduce, otherwise other formula is same. And what about osmotic pressure? You know pi V, this one is, if you remember, that one is pi V is equal to I, okay, nRT. So these are some formulas. On this basis you have to do numerical. Now just see one numerical I'll explain. First is, it's a 2011 question, board ka question. Now what mass of NaCl, it's a molar mass is given, it's a 58.8 gram per mole, must be dissolved in 65 gram of water to lower the freezing point by 7.50 Kelvin. The freezing point of depression constant Kf for water is itna. Assume I for NaCl is this. Okay, now remember one thing, I for NaCl always undergo dissociation. It is converted into 2 number of particles. Now just see formula, delta F is equal to I into Km, but instead of M you have to write expanded form, Wb into 1000 upon Wa into Mb. Same formula, only you have to introduce I, okay, for correction, as a correction factor, because you know NaCl undergoes dissociation. Now in this one, whatever is given to you, I is 1.87, Kf is given, Wa is given 65, Mb is given 58.5, delta Tf is also given to you. Now just see all these things given. Now put all the values in this and you have to calculate WB. After solving this, your answer is 8.2 gram. Okay, now one question is for you, that is a solution containing 3.1 gram of BaCl2 into 50 gram of water boils at 100.083 degrees Celsius. Calculate the ratio of Vant Hoff factor and molality of BaCl2 in this solution. Kb for water is given to you. Okay, that molar mass of BaCl2 is also given. Now in this simple, first of all calculate molality. Okay, with the help of that one you can calculate delta TB. Okay, that delta TB, whatever you will calculate, that one is your observed value. Okay, observed value means experimental value, and normal value is already, this one normal value is given to you. Okay, on normal value, sorry, that normal value, the delta TB you will calculate, that one is your normal value. Okay, and another one is observed elevation in boiling point, is that you have to calculate delta TB, that is equal to 100.083 minus 100, and that one is your observed elevation in boiling point, and accordingly you have to calculate I. Try, otherwise I'll explain this numerical in next video. Okay, thank you.